Okay, once the speed reach certain speed range, means that if we have 100% of synchronous speed, so if once it reach, let's say 80% of the speed, and it reach at almost the peak top spec, or the almost the top induced top of the main windings. So the centrifugal switch, which in terms of maybe mechanically, or it will have some sort of sensor, it will disconnect, and you will disconnect the centrifugal switch, and so the switch should be disconnected, and it will operate only on the main windings alone. Let's say if you are not disconnect the switch, so you can see that once the speed reach the synchronous speed, you have a lower in terms of speed regulation. Here we have higher speed regulation, means that the speed will not reduce once you put load, or the load, if the load is increased. But here, if you have a main and plus starting windings alone together, so you will follow the dotted lines here, and you shall have a lower efficiency kind of system compared to you just switch back to the main windings alone. So you have a better speed regulation. So this is for single phase motor using split windings. And then we have a capacitor start motor. Same per previous split windings, just we have here the element of capacitor. So the purpose of, we have two kind of windings, is that we have we need to introduce some different in terms of magnetic fields phase, and so that the motor will have some idea where to turn, either clockwise or anti-clockwise. So that's why we have here RA over XA is bigger than RM over XM, and so we introduce two kind of different phase. And so here we put capacitor in terms of to shift the phase between main winding and auxiliary winding. So same per split phase type. So what happened here is that when we put capacitor and we use this kind of method, capacitor start motor, we are able to produce, or we introduce the highest standing torque, which is more than 300% of the rated value. We have 100% of rated value. So if we use capacitor start motor, so the torque introduced to the system is almost 300, over than 300% of the rated torque of the system individually, if you use only main winding only. So this is the point where the switch will take over, because once your torque induced is reduced when your synchronous speed, the speed is almost reaching synchronous, so we will set and the switch to open, and it will run only on main winding. So you as engineer will decide where the switch will interchange between main plus auxiliary and the main winding only. So usually if you run inside your lab, you will see, you will plot only not in terms of torque speed, you will plot in terms of efficiency, power factor. So you will decide based on that efficiency of your system, the performance of the system, where the switching point should be placed at, and at what speed range the switching should place to interchange between the combination of your main and auxiliary winding to the main windings only. So it's to take over that the system are used in the application where the higher starting torque is absolutely required, such as for in compressor, aircon compressor, air conditioner, and other piece of equipment that must be started under load and full load condition. So we have another permanent split capacitor motor. So this here we have capacitor start, means that after we start the motor, we shall disconnect and the capacitor. But here we permanently intact the capacitor into the system. So we have 2 poles. So this motor have a lower starting torque. We have 100% of torque, but when we start with the capacitor, with the system, we have a lower torque, less than 100%. At normal load, this motor are more efficient. Normal load or low load, the motor is efficient and have higher power factor. You can see if you plot inside your experiment, the power factor will be almost 90% or 0.9. And smoother torque than ordinary single phase induction motor. So it means that we intact directly the capacitor to the system. We run with the capacitor. So this is the ramp or the trend of the motor. But in terms of speed regulation, means that at full speed, at full load, and at no load, the signal speed happen almost synchronous, happen at no load. But once you put load, so the speed will reduce. So the regulation will be almost will reduce accordingly. So to improve the system, we use another kind of capacitor start and run. Just now we use a fixed capacitor. Now we put extra capacitor to start and another capacitor just to run. So actually the curve will be like this, means that you have a almost the same in terms of curve, but you have a higher torque. So this one is assisting by the starting capacitor. And so once it's reached certain level of speed, you will switch to the running capacitor system and running capacitor lines here. The first you start with the main and start capacitor plus running. Then after you reach the speed, the required speed, so we change to the running capacitor only. So here what we have or what we can obtain is that if both of the largest possible torque, it will provide larger torque and best running condition. And so we have 2 capacitor to be assisted, to be installed to the system to assist the requirement if you need larger torque and best running condition. Because with the capacitor run system, we shall have a best running condition, but we don't have higher starting torque. So we have to put capacitor for the starting. So that's the only way to obtain the larger possible starting torque. So the permanent capacitor is large enough to have balanced the current at normal motor loads and can operate efficiently with higher torque and power factor. That can operate efficiently with a higher torque and power factor. So this is happen. This is on the permanent capacitor. It should be large enough to balance the current. The permanent capacitor of this motor is typically around 10% to 20% of the starting capacitor. So you shall use or perform this kind of experiment, because in lab 4 this kind of experiment will be conducted. So you shall have a starting capacitor and running capacitor to generate this kind of graph, and starting and running capacitor, and then the running capacitor itself. So you decide, and based on the performance, efficiency, power factor, the consumed current, you shall decide where are the most proper speed range before it reaches synchronous speed, or the points that you should assign the switch to interchange between the combination of both capacitor into the running capacitor alone. Okay, you shall see the response, and you shall evaluate and foresee the response. Okay, other kind of starting method of the single phase motor is the shaded stator poles. So what happens that we put a winding to provide electromagnetic rotation By right, if we put only 2 poles here, so the motor have no idea where to turn. But when we shaded this part, so half of the part is being shaded, so we have a skewed kind of poles. So means that we providing the almost to the more likely returning magnetic field. And so this one is shaded, so the poles only exposed to the bar from the unshaded one. So we rotate based on the unshaded poles. So for the shaded poles, we have only main winding, 2 windings, which is 2 poles, okay? 2 poles, north and south, but with a skewed or with a slanted construction. So shaded poles produce less starting torque, and they are much less efficient and have much higher slip than other type of induction motor starting systems. So usually this kind of motor, shaded poles used in the like your hair shaver and gunting rambut and other kind of small motor in the market. So naturally, the best motor is also expensive. Best thing usually expensive kan. And the worst motor is the least expensive. And you have a higher quality, for sure you have to pay more. Less or low quality really being offered cheaper. So that is the normal market strategy or market environment. So not all starting techniques are available in all motor size range. So if you can see from the left, so the more complex motor only applicable or being applied to the higher or bigger motor. But for small and cheaper motor, so simpler or least cost starting method being used. Single phase induction motor can be ranked from the best to worst in terms of their starting and running performance based on this list. So this is the best, so this is worst, so this is in the between. Capacitor run is the best motor, so you have 2 capacitor to be included, so you include cost. Capacitor start only, so once you start you disconnect the capacitor, so this one have only 1 capacitor, windings also the same, so cheaper than the first one. Permanent split capacitor motor, and so this one lower because we don't have to put any kind of disconnecting mechanism to the system, so least cost, least equipment or device or system to be applied to the system, so least cost. Split phase motor, and totally split phase, so you just construct in the factory, don't have to put any capacitor, so cheaper cost. Shaded pole motor, only 2 windings, and 1 windings 2 poles, so this is the cheapest in the market. But in terms of efficiency and performance, so this one is the lowest, this one is the highest one. And in terms of running, so we have here a circuit of the single phase induction motor, the equivalent circuit of the single phase at standstill. So we have here the magnetic fields, so we have here the rotor parts. R1 and X1 are the resistance and reactance of the stator windings. You is stator. Meanwhile, your is a magnetizing reactance. R2 and X2 are the referred values of the rotor resistance and reactance. So this one will represent the equivalent circuit or with the effect of the forward and reverse magnetic fields separated. So we shall see this one in the next slide.